Well, good morning, everyone. Welcome to episode 6, I think, of Constellation Crew this semester. I'm your host for this morning, Madeline Shepley, and I'm joined here by two of the lovely grad students here at Ball State University, Nicolette Terracciano and Caleb Whitcomb. How are you guys doing this lovely morning?
Pretty good, considering I'm a grad student this morning.
Pretty good. Also being a grad student this morning.
Wait, did I say grad student instead of undergrad?
Yes, you did. But I'll take grad student.
We can dream, so.
Yeah.
Well, I guess you're aspiring grad students, so in any case, clearly we are slightly sleepy. It's a side effect of the #astronomer lifestyle. But anyways, we are glad that you are waking up with us. So, we've got a great show planned for you using this lovely free software, Stellarium. It allows us to look at the night sky anywhere on Earth at pretty much any time. We are currently in Muncie, Indiana, and we are showing the sky at about, oh gosh, I gotta do some math here, almost 8 o'clock in the evening. So anything you see, you can go out later tonight, hopefully if there aren't any clouds, and see what we point out to you. So are you guys ready to share with them our program for the day?
Yeah.
Right.
Very excited.
Well, first things first, we have some, for lack of better words, current-ish events for you. So in that line of thought, do you guys know what's happening at about the end of the month, beginning of next month?
No, I don't.
Caleb?
Is this something to do with maybe an object coming from outside the solar system?
Not outside the solar system, but you've got a good thought process here. So earlier in the week, I found out that there is supposed to be a comet coming from the outer solar system, and is called commonly Comet Pan-STARRS. Does that, have you guys heard of Pan-STARRS?
No.
So Pan-STARRS is this cool telescope out in Hawaii, and Pan-STARRS, you might be like, what the heck does that mean? And it's the Panoramic Survey Telescope and Rapid Response System. Astronomers like their acronyms. So this comet that we're talking about was actually discovered by the Pan-STARRS telescope, and which is pretty cool because the telescope itself, it does a variety of research, but it's really famous for its work with near-Earth objects and just objects in the solar system in general. So we are really excited to learn about this comet, and it is actually gonna be what do you guys know necessarily about comets?
They have a very
From
large orbit.
my education as a grade schooler, like they're made out of the big giant balls of like ice and dust and rock, leftover remnants from the beginning of the solar system, basically. Kind of like how asteroids are. So
yeah, they're kind of like that. What do you know, Nicolette?
They have a massive orbit.
Yeah. So, but what do we mean? What do you mean by massive in this sense?
Well,
because massive is kind of an unconventional word.
Yeah. So
orbits.
we know that the gas giants towards the the back of our solar system, they have orbital periods of hundreds of years. They take a really long time
Mm-hmm.
to orbit the sun. The comets can, if I remember correctly, some of them can be even thousands of years.
Yeah. And they
And
have
some of them
really,
can even come to the solar system and then never come back. So
yeah, which it's funny you mentioned that because our friend Comet Pan-STARRS is from this really, really far off region called the Oort cloud, where a lot of our long period comets come from. And it's on such an orbit, it's got such like a long orbit that this is going to be its first time visiting the sun, or at least that we know about. And
Mhm.
it is actually um, predicted that this will probably be the only time we see it.
Oh wow.
So, um, when orbits have really like long orbits, do you guys know what that's called?
long orbits,
Because we have circular orbits, but there's another term for,
is it unbound orbits or is it
Elliptical?
yeah. I was looking for elliptical. So elliptical orbits, they're kind of like, for lack of better words, they're like football shaped or like rugby shaped, depending on what kind of sports you like to cheer on. And when that happens, you have these 2 points in an orbit called perihelion and aphelion. And perihelion is when you're closest to the sun. So in about, let's see, 2 weeks, Comet Pan-STARRS is actually going to be at perihelion. It's going to get about 43 million kilometers away from the sun, which is quite close. It's going to be real toasty.
yeah, it's about half the distance we are from the sun. So
Yeah. So it's going to get that close to the sun, and then about a month from now, it's actually going to be at its closest point to Earth. And it's going to be about 90 million miles away. Or not 90 million miles, kilometers. Man,
mhm.
these units are really getting me today. But yeah, so um we are hoping that we can see this comet, but
Mm.
there's some concern that it might not be very visible. Do you guys know why scientists aren't sure we're going to be able to see this comet?
My first guess was probably going to be light pollution, but considering that scientists are concerned in general, plural, there's probably something else.
Yeah, I mean,
Uh,
light
I would,
pollution is, in general, but
well,
also,
I would say it's getting closer to the sun than we are. So maybe the sun might melt it a little bit. Like ice cream on a hot day.
yeah,
So
ice cream on a hot day. That's actually a great analogy there. But that does actually get quite to the point of with comet pan-stars when something, particularly comets, get too close to the sun, they are at extreme risk of breaking apart before we see them as they head back out to the outer solar system. And there's a lot of concern that comet pan-stars might actually do that before we actually get to see it.
mm,
So that's one concern. But if it does happen to make it, uh, something else that would hinder its ability to be seen is that it's supposed to appear in the sky low to the horizon in the like west northwest. I think I wrote down that you would see it in the constellations Perseus and Cam Cam okay, this is a hard constellation to pronounce, but Camelopardalis.
mm.
I think it's
Um
pronounced camelopardus.
yeah, some of the constellations are really hard to pronounce, but that plus the fact that it's going to be during twilight, it's going to
Mm.
just make for really hard viewing, especially if you're new to observing comets. But should
Mm.
you choose to view our friend Comet Pan-STARRS, we highly recommend you use binoculars because it's going to be pretty faint compared to other things in the sky.
Will it be as bright as Halley's Comet?
Highly unlikely. Comets, one thing to note is that comets can be unpredictable in how bright they are. Sometimes they let off a lot of, their material when they get close to the sun, like the, melting ice cream analogy. But sometimes they dramatically disappoint us and they aren't so prominent. So, fingers crossed that we get a good comet this time. But if you don't manage to see it, it's not too huge of a deal because, but we 10 out of 10 recommend trying to see it if it does manage to survive its close encounter with the sun.
Do we know what the moon phase will be? I know that towards the end of the month we're expecting a new moon, but will it be around new moon time or?
I don't know because I'm not sure what phase of the, because it looks like I read that the best day. Oh wait, actually I do know. In the things that I read, the best day that they're recommending to see it, if it does survive its encounter with the sun, is May 2nd, and the phase of the moon that day is supposed to be a crescent moon. So the crescent moon and then Mercury in the Pleiades star cluster should help people find that. I forget the exact how they
Too bad it's not on May the 4th, because then we could say, May the 4th be with you.
especially if finding the comet. But you'll be able to see it, it's just if it survives. But it's not supposed to be the best day to see it.
Okay.
So
cool.
Good luck, everyone, trying to find the comet. But that's not the only current-ish event that we want to talk about. So, Caleb, why not you tell us about our next thing?
Oh yes. Okay. So giving a heads up for all you, those who love, awesome events. In 2 years from today, and a few hours, there will be a total eclipse of the sun, which will actually come straight through southern and central Indiana.
That's amazing. So I gotta put on my solar eclipse glasses. Oh wow, these are really dark.
Yep, you definitely do want those. So
yeah, well, I definitely don't recommend using them while you're looking at the computer screen because you won't be able to see anything. But if you want to see the sun, please put them on. So, what do we know? What do people need to know about the solar eclipse 2 years out?
So for one thing, you'll need to be in the right place at the right time. So for Indiana, you'll need to be more in the southern and kind of central part of Indiana to be able to see what's known as totality when the sun is completely eclipsed by the moon. So otherwise, you'll only see a partial eclipse.
So if I go back home, I'll be out of luck in seeing the total solar eclipse.
I'm guessing your home is Northern Indiana, then yeah.
Yep, Northwest
But if you
Indiana.
were to say be here in Muncie or Indy, you would actually be able to see the total eclipse. And actually, the best place in Indiana to see the eclipse actually would be Bloomington. So
woo-hoo!
Shout out to all those. Shout out to IU guys, because I know Madeline, you were from IU before, so
yeah, I have a love for things Ball State Cardinals, but I will always have room in my heart for the Indiana Hoosiers. And if
I like the one pizza place down there called Mother Bears.
See, I'm not so much a fan of Mother Bears. I think the pizza's overhyped, but that is beside the point. But yeah, so in any case, you can come here to Muncie, you can go to Bloomington, you can go to Indy.
Yep. So
how long are we expecting totality to last?
So those who might remember the eclipse, like back in 2017, it was called the Great American Eclipse. That was about 2 minutes, at least 2 minutes long. This one is double that. This is for some areas, it's almost 4 minutes total. So like
Yeah.
in Bloomington, it'll be about 4 minutes. For Indianapolis, it'll be just a 15 seconds less. And
Yeah.
basically you want to be close to the center of the eclipse path as possible, because that means
Yeah.
you'll get the longest time of totality.
Yeah.
So
So while you were telling us about how long totality or, you know, the whole sun being covered, I actually pulled up my own picture of the Great American Eclipse of 2017 so that people can kind of get an idea of what they might see in the sky when they try to see the total solar eclipse.
mm.
Because it's never a bad idea to hype up a solar eclipse.
Well,
So,
be careful
it
with the
is
hype because
it is
talking from
I is an
experience.
experience like no other. I can tell you that from experience. So
yeah, I 100% agree. I skipped my first day of class my sophomore year of my
mm.
undergrad to go see this, and I regret nothing.
I think Dr. Barrington actually also canceled class to go see it. Um,
Man.
and I actually, for me, it got me to go. Inspired me to go back to school. So for me, it's a very formative experience in my life. So
Yeah, it's a great event, and unfortunately, weather in Indiana is not necessarily cooperative, as the clouds outside the windows here at the planetarium
yeah,
say. But
April is not the greatest weather in Indy. Um,
we're hoping for good weather in 2 years.
so,
So
and I would recommend for those who want to see the eclipse, be sure to check the weather and the possible climate in the months beforehand, and be prepared if you're going to want to see it, to be prepared to travel. So
yeah, if only the eclipse came during a month with better weather. But
if it was like June or July, it would be very much better.
yeah, we can't have all the nice things in the world. So
So
here's to hoping for good weather. But in any case, now that we've gotten some current events out of the way, Nicolette, why don't you tell us about the first constellation we want to discuss today?
Okay. So we've kind of talked about this constellation a lot, but
Yes, we
it's a
have.
popular one. It has a very common asterism within the constellation and all that fun stuff. But we're going to go back to Ursa Major, also known as the Big Bear.
Woohoo!
Now, yes, it is the Big Bear. That is the constellation. You may think that Ursa Major is the Big Dipper. That is an asterism, which we defined last episode as a popular grouping of stars with a popular name, but it's not recognized as one of the 88 constellations. And I'd like to specify that we talked about the Spring Triangle last week. That is an asterism made up of three constellations, or
Yes,
three
we did.
stars that are a part of three separate constellations. So an asterism doesn't necessarily have to be a part of a constellation to be an asterism. It can be any grouping of stars. But
Yeah, so I guess we can make up our own asterisms if we were
I have
feeling
done
real
that.
creative.
Or I think Dana showed me last week. What was it? It was someone's mirror. I don't remember which mirror it was, but the asterism was called someone's mirror, Orion's mirror, someone's mirror. And I've recognized that shape my entire life. I just didn't know that it was an actual asterism. I just thought it was my own shape that I made up myself. Nope.
Yeah,
It's a very, very popular
I'll
asterism.
I
have to
cannot see
ask her
Orion
about
having
it.
a mirror.
I'll have to ask her about it later because I think she would be thrilled to explain it again.
Yeah, because it is one of her favorites as well. So
So why do we want to talk about Ursa Major again? Because as you said, we have talked about Ursa Major a lot. I mean, not without reason, since it's fairly prominent in northern Indiana skies. But why do we want to talk about it for like the millionth time?
Well, it has a lot of fun stuff about it, which some of the stuff we'll get to later. But one of the first things on our list is to talk about how there are stars in the constellation that are not a star. They're stars plural, but they appear as a star to us.
What do we call
And
those, Nicolette?
that's a great question. So there are many names. A binary star group means that it is two stars orbiting each other. They're gravitationally bound to each other. However, it can be more than that. It can be 3 stars. It could be
Whoa.
4 stars. In the cases today, we're talking about 2 pairs of binary star systems orbiting each other.
That's kind of wild. Like
Yeah,
that seems something like straight out of Star Wars, not gonna lie.
exactly. Those who came to Astronomy
Tatooine
Slam, I
is
made that
two
reference in
suns.
my presentation.
I
uh,
mean, how can when you bring up like binaries, how can you not bring up Tatooine? I forget the exact nature of this system, but in Star Wars, but it's
Mhm.
quite
yeah.
famously involves binary stars.
Yes.
Now I'm still thinking of that music playing on the Tatooine sunset. Ba, 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 ba.
Yeah.
Mm-hmm.
But so if you look at Ursa Major, actually we're going to look at the Big Dipper because that's where one of the first multi-star systems is located. It's in the handle. So when you're looking at the handle, there's 3 stars that make up the handle. It's the middle star. So not the very end and not the part that connects to the bowl, but the part that's in the middle.
I'll bring up Ursa
So,
Major here. Oh
okay.
my goodness, what did I do? Have no fear, I know how to fix it.
But it's this particular star in the constellation is very intriguing, mainly because it does have those 2 pairs of binary star systems orbiting each other. So you got 2 stars and 2 stars, and then those 2 stars
Mm-hmm.
orbiting each other, as well as individually. It's a bit complicated, but it's pretty cool. But it's also what's called a visual binary star pair because there's a star right next to the other one. So there's one called Mizar or Mizar, Mizar, and
Yep,
then there's another one called Alcor.
we're talking
Yep, that one
about
right
it
there.
here, folks.
Mm-hmm. So it's called a visual binary because you can see it. You can see them, the 2 stars separately without much help from extremely awesome observatories. You can see it most likely with binoculars or a telescope if you were to aim your telescope that way.
Yeah.
You won't be able to see the binary star pairs with a telescope or binoculars, but you'll be able to see Mizar and Alcor.
Yeah. For some reason, I'm not seeing my stars, but this is where they are.
Yes. So there are a couple of other ones in the constellation. One of them's called Omega Ursae Majoris. That's the fun names of constellations, stars within constellations. You get the omegas and the alphas and the betas. So Omega is located in the first back leg of the bear. That is also just a binary star system. So it's 2 stars that are very close together. However, they are so close together that they touch. They are what's called a contact binary. So they are just touching each other. And then the last one is called IOTA, IOTA, Ursae Majoris, which is located in the front leg, but in the foot. So when you're drawing the bear, sometimes there's little feet at the end of the legs, and sometimes there's not. There we go. But that is another 2 sets of binary stars again. But again, all of this appears to us as one star, except for that visual binary that I talked about earlier with Mizar and Alcor. But most of all the stars that we just talked about seem to appear to us as one star, but it's actually multi-star systems.
Yeah, those are quite cool.
But Ursa Major is more than just a bunch of stars, we can actually use Ursa Major for a lot of things, including finding the North Star.
Yeah. So, how do we find the North Star using Ursa Major?
So we're going to use the popular asterism, the Big Dipper, and we're going to go towards the end of the bowl or the ladle or the spoon, whichever you want to call it, the dipper. And we're going to use those two stars and create sort of a straight line towards a star.
Yep.
So let's see if we can make it to the North Star.
I've always thought of it as more like a frying pan, like
There we
like
go.
There you go. Yeah.
I don't know why the
you know,
stars
you
weren't
could go
necessarily.
some eggs, maybe some hash browns, you know.
So
Start your eggs.
we, now that we actually have the stars turned on, we
Mhm.
can finally. So you're saying these two stars will help me find our friend Polaris?
Yes. So it's a bit complicated because Polaris, even though it's our North Star, is not the brightest star in the sky. It's actually
It is
pretty
not.
faint to compare to most stars. However, how I think of it is that these two stars will point you almost directly to the star. So you're not going to breeze right past it. You're literally going to make a straight line and hit the star. You're going to be going in between stars along the way or just barely touching the star along the way, but you're actually going to make contact with Polaris when you use the two stars in the Big Dipper.
So, as you can see, I decided to cheat a little and use Stellarium to help me find it. As
Mhm.
a testament to how difficult it can be to find sometimes. But,
Yes.
woot. And there's our friend Polaris.
Yes, which is a part of Ursa Minor, the little bear.
Yeah, look at that little baby bear with his fluffy little tail.
Yeah, every time I see the bears, like, wait, do bears have tails like that?
So, for those who like using outside resources to do some of the stuff that we talk about here in Constellation Crew, there is a website called skymaps.com. You can download and print for free the sky map of the month so that you guys can take a look at the constellations. And sky map actually
Yeah.
does show you this trick that we just taught you. It shows you on the map how to do that as well.
Yeah, because let's be real, trying to do it yourself sometimes is a little daunting.
Yes, especially if you're in a place with a lot of city light. I will tell you right now, back home, I cannot see Polaris.
I
I know
can.
what it's supposed to be.
See, fortunately, I live, I think, a little bit farther away from Chicago than you do. So it's a little bit easier to find Polaris, but Chicago is to the northwest of where I live. And,
Mm.
well, our friend Polaris is the North Star, and so it is a little bit affected by the light pollution from the city of Chicago. But it is what it is. So
Exactly.
at least I can see our little guy here.
Yes. Cute little bear.
So Polaris, of course, is interesting because it is our current North Star, but is it always going to be our North Star?
No, it's not.
Then why isn't it going to be our North Star always?
Well, first off, let me warn the audience here. This is a very complex topic that even I, as a college undergrad in a major of astronomy, have a hard time grasping on occasion and need a lot of visuals to understand. So we're going to try our best to explain something called precession. This is something that the Earth does. So we're going to start with one of my favorite analogies that helps me out a lot. So for all of those who've had a top at home, so you spin the top, right?
Definitely have.
Yes, you're spinning it around. So imagine that Earth is this top, right? So Earth is spinning on its own axis, like the top is doing, it's spinning on the table. And then the top, or Earth, is now orbiting the sun while spinning on its own axis. There's another spin, or a wobble, if you will, is a better word to say. It's a wobble. So if you watch the top after a while, when you're a kid, you try to make it spin super fast so that it lasts longer.
Yep.
And then towards the end of the top's spinning, it starts to wobble a little, and kind of the tip of the top towards the top, if you will, of the top. It's a lot of tops. It starts to trace a circle as it's wobbling around and is about to wobble over and fall over. That is what the Earth is doing. However, the Earth is not going to fall over, so don't worry about that.
Oh,
But
good. We wouldn't want to, like, just go.
exactly. So the Earth is wobbling like the top, and it's tracing a circle. So keep in mind that this circle takes 26,000 years to complete.
That's a long time.
Yes, a very, very long time. So we'll have Polaris as our North Star for a bit,
So
quite a long time.
Actually,
we don't have to worry.
Actually, I think in the next 100 years, actually, we'll get a lot better as the North Star, as the North Pole star. So
Exactly.
So basically, the moral of the story is that in our lifetimes, in our grandkids' lifetimes, our great grandkids' lifetimes, we won't have to worry about uh, becoming friends with a new North Star.
Correct. And exactly like Caleb said, if you actually look at Polaris in the general direction of north, you can see this in a lot of planetarium stuff. It's slightly off, slightly, not enough to notice right away, but very slightly.
As you can see, it's not quite on Polaris. If I go from our little N to mark the cardinal point of north on our horizon line.
Exactly.
It's close, but not exact.
So Caleb is exactly correct in saying that it'll become a lot better of a North Star before it even comes close to not being our North Star anymore. That was a very complicated way of saying it, but it will get better before it gets worse. I guess is the better way to say it.
You're not wrong. You're honestly not wrong. So Polaris, of course, is cool, and Ursa Minor is really cool. Is there any other cool things about Ursa Minor related to it that we need to bring up?
Yes. So because of the North Star situation, what makes it the North Star is that the Earth's North Pole, or axis pole, is pointing at Polaris. That's what makes it the North Star, and that is what's going on with precession. That tip of the top, our tip of the top for Earth is
Here's
our North Pole axis. And of course, it's the same for the South Pole axis as well. But the important thing about this is that since this is happening, this creates what's called circumpolar stars and circumpolar constellations.
Yeah. So can you explain to us what circumpolar means? Because I'm sure some of our viewers are like, what? I've never heard this word before.
It is a very big word, but it's very simple. So circumpolar stars and constellations are those that are up above the horizon all night, every night of the year for a given location. So that's the very specific part. The crew was actually talking about this earlier because Madeline and I don't live in Muncie. We come here for school. I live in Illinois, very far north. And so I was under the assumption that the Big Dipper is circumpolar, always, everywhere.
Well, I was under the impression that it was circumpolar as well, because I live in basically near Lake Michigan in Indiana. And so I live a lot farther north than Muncie as well.
However, it is a location thing. So here in Muncie, and you can even see it now in Stellarium as Madeline is moving time, the Big Bear, Ursa Major does go below the horizon a little bit. And because of that, Ursa Major is not circumpolar.
Yeah. I believe you and I, when we go home, we live like right on the edge of where it's circumpolar. Hence our lack of knowledge and lived experience in the subject.
Yes. But to make things easier for a moment, forget about Ursa Major just in case it's starting to become confusing. A constellation that is circumpolar in the northern hemisphere is Ursa Minor.
Yep. as you can see.
Oh, I never would have guessed that.
As you could see from my making our friend Ursa Minor go round and round in circles, you can see that never went below the horizon.
Right. And neither does Polaris, the North Star. So Polaris, the North Star, is circumpolar individually as a star as well. And all the stars kind of, I don't want to say orbit around it, but they kind of just make this circle around Polaris.
It's kind of like Polaris wants to be the center of attention for a little bit.
Yes,
Well, it'll get to be
exactly.
it for a little bit, but
Yeah.
Mm-hmm.
Which, honestly, speaking of Polaris only being the center of attention in our northern night sky for a little bit, that kind of brings us to our next topic, which, Caleb, why not you take it away?
okay. Our next constellation, for the again, I am also bringing up Harry Potter again because
Oh,
it's a constellation
always.
with a name of character people might be very familiar with, known as Draco the Dragon, or for those Harry Potter fans, Draco Malfoy, the
Good old
everybody's
Draco
favorite Slytherin.
Malfoy.
So,
So, why do we want to bring up our friend Draco? Why is
oh,
Draco
I'm
special?
so glad you asked. Draco is actually particularly interesting because there's a certain star in there, um, which actually at one point in time in history was the North Star.
Whoa,
That
Polaris
star,
wasn't always the North Star?
oh no no no, no it yeah, it wasn't always. Now, granted, this is very early history. So this star is known as Thuban, or by astronomers is known as Alpha Draconis.
Alpha Drac. Now, if I wanted to find Alpha Draconis, how might I find our friend Thuban or Alpha Draconis? I think it's this one. But for those who are maybe not so certain, how, do you know how to find it or
Actually, I am actually not entirely sure how to find it actually, but
let's see if
I
I
do
can.
know it is not actually the brightest
Oh,
star
that's
in Draco. Actually,
it's not.
yes, that's that. Is that most of the time astronomers give the name of stars in a constellation based on their brightness. So like, say Alpha Ursa Majoris is actually the brightest star in Ursa Major,
Mm-hmm.
but even though Thuban is Alpha Draconis, it is actually not the brightest star in
Here we go.
the constellation, and
So
that likely has to do with the possibly has to do with the historical significance of Thuban itself.
yeah.
So,
So for those of you who want to know where Thuban is in our friend Draco, Thuban is right here, and it kind of looks like if you draw a line from the what are we gonna call this? The handle, or I mean the top part of the dipper. You can kind of draw a line from the Little Dipper to Thuban. I've not personally gone out and tried this, so feel free to go out and try this yourself. Anyways, you had some other cool stuff about Thuban and Draco, correct?
so it actually was the North Star um, from like the fourth to second millennium BC during the ancient Egyptian times, actually.
Wow.
And it was, I mean, that's actually kind of part of how like the precession was kind of like inferred because during the Greek times there was this guy known as Hipparchus, who actually was looking at Egyptian star maps and noticed how the constellations from his time and the constellations during the Egyptian times actually were quite different. So that's how he noticed that the North, such as pole, actually the North Point, was actually moved from Thuban uh, to Polaris.
Wow. It's really interesting that our ancient friends back in the ye old days were able to kind of infer that from studying past civilizations compared to their own. So,
So
are there any other cool things about our friend Draco?
Well, I know this is usually Nicolette's portion, but like in mythology, Draco the represented the dragon known as Ladon, who who guarded this mythical garden known as the Garden of the Hesperides. And everybody's favorite Greek hero Hercules had to steal a golden apple from this garden from from the dragon. So
Wow.
in the story, as one of his 12 labors. So in the story, he tricked the Titan known as Atlas, who was his punishment for fighting as the gods was to bear the weight of the sky for all eternity. He tricked him by taking the burden from him, and then got him to take the apple for him, and then tricked him into taking up the sky again. So
Dang, Hercules was quite the trickster.
yeah. So like Hercules was definitely very smart. Was very smart when he yeah,
Yeah,
not just strong. So
you kind of gotta be, you gotta have some brains and some brawn if you're gonna go through the 12 labors he had to go through. So,
yeah,
my props to
so
Hercules.
yeah,
You're talking about Greg's cat or actual Hercules?
I, good point. Definitely our friend, the Greek hero, but
yeah.
also,
I
from,
mean, who knows? Maybe Greg's cat did steal a golden apple.
Ooh.
yeah, I bet Greg would love it if, his cat Hercules, stole an apple, but for all accounts, I know that Greg loves his cat Hercules very much. So
Mm,
I guess both Hercules that are near and dear to us are cool.
yep.
So is there any. Actually, speaking of cats, I believe there's one more thing to bring up about Draco.
Why, yes, there is indeed. There is a particular nebula in Draco known as, get this, the Cat's Eye Nebula.
Oh,
Phenomenal. So, can you tell
wow.
us
I do.
briefly about the Cat's Eye Nebula as I bring it up or
Well, it
attempt
is
to?
what is known as a planetary nebula, which most time people think of nebula as the birthplace of stars, but actually, this is actually the remnants of a star that died a long time ago.
Here we go. There's a somewhat low res image
Yep.
of the Cat's Eye Nebula.
So,
Hmm.
and actually, despite it being the remnants of a past star, it is actually only 1,000 years old. So, in astronomical times, that is very, very young.
Yeah, 1,000 years is practically like a toddler in
Yeah.
Wow.
So
astronomical
That number
timescales.
just hit me. I was expecting hundreds of
I once
thousands.
read in the textbook that like if we you say the time the entire age of the universe was was put in the span of an entire year, human civilization itself, the entire human civilization, which like thousands of years, wouldn't even be in like would be like in the last half minute of the last day of the last part of the year.
Yeah,
So
I think I'd heard that before, and it's kind of mind blowing to think that we may think, decades is a long time, but that's only in human scale. In
yeah,
astronomical scale, it's a blink of an eye.
I wouldn't say it's even a blink of an eye.
Yeah,
I'd
it's
say
like a
like
fire
maybe
of a
more of a
neuron.
twitch, twitch the eyelash. Yeah.
Yeah. Yeah,
So
oh, man. We got some. So, Cat's Eye, it's a pretty cool nebula. I don't
yeah,
remember if it's. You can see it with. You definitely can't see it with the naked eye, but you might be able to see it with a telescope of the appropriate size.
yeah.
So, perhaps some people out there can go and try and see it if they're feeling really ambitious like Hercules. But in any case, we
You talking about the
are.
hero or the cat?
The what?
We're talking about the hero or the cat.
Well, I don't know if Hercules the cat can use a telescope. Greg can confirm or deny. But Hercules the Greek hero was uh human in form, so he could probably use a telescope if they existed uh in his realm of the world. But we are almost, or well, pretty much at our time. So I would love to ask if you guys have any last comments.
I'd like to challenge our viewers to remember that a circumpolar constellation or circumpolar star is one that stays above the horizon every night of and every day, all night of given year at your location. So if you guys are here in Muncie or not in Muncie and Little Dipper doesn't count, Ursa Minor doesn't count, that's the easy one. Try and find a circumpolar constellation from your location and let
Hint.
us know in the chat if you find any
Yeah.
that
Hint, hint.
I personally would be
This
fun.
probably, Draco's probably a circumpolar constellation.
Yes, as long as it doesn't go below the horizon in your location. Another freebie.
Yeah, we're helping you out. Caleb,
Yes,
any
and
last comments?
I would say everybody, start your timers and get excited because 2 years from today we'll get our great event with the eclipse. So,
Fingers crossed for good weather.
yeah.
oh please, good weather. I would love that.
Yeah, and we hope that you guys have fun observing the night sky this weekend, tonight, whenever. Don't be afraid to challenge yourself to try and find these constellations and more that we mention. And if you're struggling to find them, use a sky map, a sky app, whatever have you, tools to get the job done. And last but of course not least, if you guys want to reach out to the Planetarium, I have put our social media handles on the screen. You can use our social media to stay up to date on all of the happenings at the Planetarium, including our free public shows and other events that we host. But until our next program, which I think is next Friday, we hope that you guys stay starstruck. So, see you guys next time.